Lesson 5-5 is on direct variation. Our learning target for today is I will identify, write, and graph direct variation. These will be some new terms that you'll be seeing in this lesson. Alright, starting out, you've been seeing things that are direct variation for a long time, but we've been using the word proportional, or we just got done talking about slope, where we talk about a constant rate of change. They're all the same thing. So if things vary directly, they have a constant rate of change, they're proportional, they're all the same thing. So in this case, they're just saying a recipe for paella calls for 1 cup of rice to make 5 servings. In other words, a chef needs 1 cup of rice for every 5 servings. Going through here, that we can just see that the same thing is happening as a constant rate going through here. Constant is changing by the same number, so we can say that these vary directly. We can make an equation out of this because looking through the connection between x and y, we're just taking the x and multiplying it by 5 every single time. So your equation would be y equals 5x. To describe this relationship, the number of servings varies directly with the number of cups of rice. So again, this really isn't anything new. They're just giving you some different terms to focus on. So direct variation is a special type of linear relationship that can be written in the form y equals kx, where k is a non-zero constant called the constant of variation. We're going to show very quickly that the constant of variation is just the slope. So they're using the letter k right now. I know it's kind of confusing because we just learned that the slope would be the letter m, but just know that these are the same thing. The constant of variation is the slope, but in this case they're going to use the letter k just for today. So first thing we're going to do is tell whether this equation is direct variation. If so, identify the constant of variation. So we're just looking to see if it's in this form, where y equals 3x. We're just looking to see if it's nothing else is going on except we're just multiplying something by the x. That's all we're checking for. In this case, that's it. We're just doing whatever x is, we multiply it by 3. We're not adding anything, so we can put it in this form of y equals kx. So there's no addition. Sorry, I'll go back to that. There's no addition or subtraction. So we can say that yes, this is direct variation. And in that case, the constant of variation is 3. Or we could say later on the slope is 3. If you look at this one, see if this is going to be a direct variation. You notice that this one is actually in standard form. So if things are going to be in direct variation, they need to have the y by itself. So the first thing you would do would be subtract 3x from both sides. You end up with y equals negative 3x plus 8. So this is not direct variation because of the plus 8. If it was just the y equals negative 3x, that would be fine, and then the constant variation would be negative 3. But because of the plus 8, this is not in direct variation. Another one here, same thing. This is in standard form, so we're just trying to get the y by itself. So first thing we would do is move the negative 4x to the right hand side. We have 3y equals 4x. Now we have to do one more thing from here, and that is to get the y by itself by dividing by 3. So we'll do that here next. We're left with y equals 4/3 x. So we're checking now, is this in direct variation? And yes, it is. All we see is a number multiplied by x. So this is direct variation, and the constant of variation is 4/3. Alright, try this one out and see how you do. Hit pause now. And we're back. So it's a no. Hit pause for this one. And we're back. So this is a yes. And the constant of variation is negative 3/4. Try this one out. Hit pause now. And we're back. So this is a yes. Constant of variation is -3. Alright, so what happens if you solve y equals kx for k? So instead of getting y by itself, get the k by itself. So looking at that, we have y equals k times x. Undo this multiplication with division and divide both sides by x. Then you have y over x equals k. This is just nice to know because now we know that if we can figure out, if we know something about the y and the x, like one certain ordered pair or one piece of data, we could just take a y and divide it by x, and that would give you the k, or the constant of variation. Alright, so looking through, tell whether this table shows direct variation or not. So one thing we could do is we could just write an equation and see if we see a connection here. So what's going on between the x and the y? It's like 2 to 6, 4 to 12, 6 to 18. It's multiplying by 3. So we're seeing that pattern where it's just y equals 3x. So that is showing direct variation. There's no other addition or subtraction going on. There's no exponents. It's just multiplying by 3. So the constant of variation would be 3. And we can just see that the constant is just the number in front of the x. That's going to be the 3. Now another option here is to find an x, y, and just divide them. If we're seeing that they're doing the same thing, if we do 6 divided by 2, we get 3. If we do 12 divided by 4, we get 3. And 18 divided by 6, we get 3. So the same thing is happening for each ordered pair. So again, that is proportional. It is a constant rate of change. Those are all the same thing, which all means direct variation. So just another way to show that the constant of variation would be 3. So try this one out and see about this one. Going through here, we can just check what's going on between 1 and -2, 3 and 0, and 7 and 4. Well, actually, it appears that this is adding 3 for each one, or actually, for this one here, actually subtracting 3. So if you take your x, you're just going to subtract 3 to get this. So x minus 3. This is not showing direct variation because it is not something multiplied by x. So this is not direct variation. Just to double check that, you could also do this by dividing. And if we are to divide -2 by 1, you get -2. Divide 0 by 3, you get 0. And 4 by 7 is 0.57, and it's going to be an ugly repeating number. Looking through here, they're all different, which means there's nothing, these are not proportional. These are not a constant rate of change, so it just means that it's not direct variation. Try this one out and see how you do. Hit pause, and we're back. This one's a no. Try this one out. Hit pause now, and we're back. This one is a yes, where the constant is -4. Hit pause now, and we're back. This is not showing direct variation. Okay, another option here is they might tell you this: the value of y varies directly with x. So we're just knowing that it is direct variation. We don't have to prove if it is or not. They're going to tell us that yes, that x and y do vary directly. Now they're going to give us some values. So y is 3 and x is 9. So it's like the order pair 9, 3. They want us to find y when x equals 21. So with that initial data, we can use that to figure out what the k would be first. So if we go into our formula of y equals kx, or just try to solve for k, we know that 3 is y, 9 is k. So to get k by itself, divide both sides by 9 to get 1/3 for k. So we now know that we can make an equation that would look like y equals 1/3 x. Now they want us to plug in 21 for x. So 1/3 times 21 down here would give us 7. So the answer to this situation would be 7. Now, when I talked about how varying directly is the same thing as proportional, hopefully you thought about using a proportion, and that would still work. You did a lot of this last year, so we could just set this up and just say we know x and y, put them together in the same order, so y on top, x on the bottom, and then over here x, you know your x, you don't know your y. So there's different ways you can solve this. You want to cross multiply, you can, but either way you'd find a value of y for 7, or 7 for y. So that works out just as well. So two options that both work out just fine. Try this one out and see how you do. Hit pause now. And we're back. So this one would be 90. Try this one out. Right, actually it's the same one, but just using a proportion. So we can just walk through this one and see how it looks. And we can see that we get the same answer either way. Alright, finally. A group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that the people will float in x hours, then graph it. Okay, so this is direct variation, so we know it's going to be in the form of y equals kx. We know we're going 2 miles per hour, so it's going to be y equals 2 times x. Now, they're saying choose some values of x and generate ordered pairs. So we can just, again, pick some random points here. I think we've done in the past. You can use 0, 1, 2. The point of that is to graph it. Once we have our graph, or we could also use a graphing calculator. The key thing with this is that we see when the graph through here, every direct variation graph will go through 0, 0. That's just kind of a given for all these problems, that because we're not adding anything or subtracting anything, we're always starting at 0, 0. So just know from here on out, anything that is direct variation, the graph always starts at 0, 0. Here's a last example you can try on your own. So I hit pause, and we're back. So y equals 4x. Find some different ways to graph it, and notice that in this final graph, it goes through 0, 0. And that is all.